All right, so at this point, you guys should have already completed Exploration 5-4, where you were getting some practice finding values of sine and cosine. You were doing this with angles in standard position. And so like on this first one, we had a 123-degree angle. Since this angle isn't significant, you should have found these values using your calculator. For number 3, you had a coordinate point, so you were able to draw a triangle in the third quadrant and find the exact ratios. Keep in mind the other day I talked about rationalizing answers, but with these ones, since they're not a part of our special right triangles, I'm okay if you would have left your answers like this, but if you did rationalize them, they would have ended up looking a little bit uglier. It would have looked like these two fractions here. And then number 4, you're given an angle. So this is similar to number 2, but the 300 degrees has a reference angle of 60 degrees. And so that made this a special right triangle. So we didn't have to type these answers in our calculator. We were able to get exact ratios based off of that special right triangle. So we are going to add on to what we know about our trig functions. And so before we do that, we're just going to kind of go back to the basics real quick. If we are looking at a triangle, a right triangle, and we have our angle here, theta, as our reference angle, we know that this side across from it is considered the opposite side. We know this side next to it is considered the adjacent side, and then the longest side across from the 90 is considered the hypotenuse. We were a little bit pickier with these definitions, and we started calling the opposite side y, the adjacent side x, and the hypotenuse the radius, and we still will. When we talked about SOHCAHTOA, they were 3 different ratios of our side lengths. And so sine was opposite over hypotenuse. But one thing that we haven't talked about yet is what if we wanted to take the hypotenuse over the opposite? The cosine was adjacent over hypotenuse, but what if we took the hypotenuse over the adjacent? And then last, tangent was opposite over adjacent, but what about the adjacent over the opposite? So what I'm trying to get to here is there are actually 3 more trig ratios. They're not commonly used, but they exist and we will see them periodically. And so in your notes, this is section 5.4 notes. You should already have a chunk of this filled out, the special triangle section here. But these are the other trigonometric functions. Again, because there are 3 side lengths in the triangle, technically we could find 6 different ratios. So we know that sine is opposite over hypotenuse, so a new trig function that you haven't heard about yet is called cosecant. And that is the reciprocal of sine. So you could think of it as 1 over sine, or hypotenuse over opposite, or radius over vertical. That would mean that sine's definition was vertical, which is y, over radius, r. I'm going to start abbreviating that. We know that cosine is adjacent over hypotenuse, and now a new trig function is called secant. That's the reciprocal of cosine, so we can think of it as 1 over cosine, which is the hypotenuse over the adjacent, or we could think of that as the radius over the horizontal, r over u, or we use x a lot more often too, so you could say r over x if that makes a little bit more sense to you. Tangent is opposite over adjacent, or we could think of that as the vertical y over the horizontal x. Again, if you want to use these definitions, you can. They're all the same. And then our new trig function is called cotangent. And so that's the reciprocal of tangent and compares the adjacent to the opposite. Okay, so we're going to continue doing what we've been doing, but now we're going to just have these 3 new trig functions to consider. And so the first thing that we're going to figure out is, how do I type these in my calculator? So I'm going to switch over to Desmos here. When you click into Desmos, you can get this keypad, And so if you go into functions, you will actually see all 6 trig functions here. And that's great, but I do want to teach you guys how to do it without these 3 buttons. Just in case you're on TI-84, like taking the ACT or something like that, and these 3 buttons aren't usually on most calculators. So I'm going to go ahead and just do sine, cosine, and tangent, and I'll type in those angles here in a second. Also be mindful, and I've kind of warned you about this year, or this past couple weeks already, that when you go into Desmos, you need to go over to this wrench here. Sorry, my keyboard keeps popping up. And you need to make sure that you're in degree mode, otherwise you are going to get the incorrect answers. Radians is a different form of measurement we will talk about in future chapters. And so I have sine of 58.6. We have cosine of 50, this is going to be annoying, 0.6. And maybe I'll embrace it. There we go. And tangent of 58.6. So we have the ratios 0.85, 355, 0.521, 1.6. Okay, so nothing new here. Now, if you think back to the definitions that we just learned, the reciprocal of sine is this one called cosecant. So if we're trying to find the cosecant of 58.6, what I can type in is 1 divided by sine, and that will find the reciprocal for me. And so I'm going to go back over here, and we will do 1 divided by sine of 58.6. And so we will end up getting 1.17-ish. Secant, then, you'll want to know which one is the reciprocal. Secant is the reciprocal of cosine. One way that I remember which go with which is S and C's. So sine, cosecant, cosine, secant. So S, C, C, S. And then tangent and cotangent are nice because they share the name tangent. And so that's one way that I use to remember those there. So for sine, we got 0.8536. For cosine, we ended up getting 0.5210. Tangent, we got 1.6383. Cosecant, we will type in 1 divided by sine 58.6. That will give you 1.172 if you round. This you would type in 1 divided by the cosine of 58.6. We get 1.9194, and cotangent 1 divided by the tangent of 58.6, and we get 0.6104. Okay, so I'm going to go ahead and recommend that you pause me here in a couple minutes, or in a couple seconds here, and you're going to look at Exploration 5.4a, and this is going to be your chance just to get some practice. So right away on number 1, it's just asking us to write the definitions of the 6 trig functions using u, v, and r. Okay, so if you wanted to change it to x, y, and r, that's fine. It really doesn't matter to me. And so sine is opposite over hypotenuse, or v over r. Cosine is adjacent over hypotenuse, u over r. Tangent's opposite over adjacent, v over u. And then cotangent, you flip tangent around. The reciprocal would be u over v. Secant is the reciprocal of cosine, so r over u. Sorry, my writing's getting kind of smushed here. And then cosecant is the reciprocal of sine, which is r over v. So I would pause this video, and I want you then to try number 2. Where you could sketch the 123-degree angle in standard position, and then you are going to find the values of the 6 trig functions. Also, this ellipsis format just means that you can chop off the decimal and write dot, dot, dot. So instead of rounding, you can just stop writing numbers and write dot, dot, dot. 3 dots is called an ellipsis. Okay, so go ahead and pause this right now and try number 2. So now you can go ahead and check your answers, make sure that you found those correctly. Number 3 asked, explain why that the sine of 123 is positive, but the tangent is negative. And so this goes back to the fact that our angle is an angle in standard position, and we are in the second quadrant where x values are negative, y values are positive. The radius is always positive, and so tangent compares y over x, which would end up being a negative number when you divide that ratio, and sine would be y over r, which ends up being positive. Okay, so I'm going to go ahead and move on to number 4 in Exploration 5.4a. And so now this problem's a little bit different in that we're given an actual coordinate that our terminal ray is crossing through. And so we can construct our right triangle, label our side lengths. X is -3, y is -7. I'm going to come over here and do Pythagorean theorem to find the length of the radius. So we'll end up getting 9 plus 49 is equal to r squared, and so r will equal the square root of 58. So the cool thing is, you guys, is the 3 new trig functions shouldn't make your life any harder. I am going to rewrite them over here off to the side, just so I have a little bit more room to write. So cotangent of theta, secant of theta, and cosecant of theta. So if you find the first 3, no problem. The next 3 are just going to be the reciprocals. And so sine, here's my reference angle, is opposite over hypotenuse. So -7 over the square root of 58. That is an exact answer, like the directions are asking for. So I'm not going to type this in and get a decimal. I'm going to leave it like this. And also, this isn't that special of a ratio, so I'm just going to leave it in improper form and leave that radical down there. That's completely fine. Cosine is adjacent over hypotenuse, or x over r, so that'd be -3 over the square root of 58. And tangent opposite over adjacent, -7 over -3, which notice a negative divided by a negative will actually give us a positive. So once you find these first 3 ratios, the other 3 are just the reciprocals. Cotangent is the reciprocal of tangent, 3 over 7. Secant is the reciprocal of cosine, square root of 58 over -3. Cosecant is the reciprocal of sine, square root of 58 over -7. That is number 4. Okay, looking at number 5, it's somewhat similar to number 2 because we're given an angle again. However, it's asking us to find exact ratios here. And so with this one, we had to ask our calculator for these answers, and these are approximate answers. But number 5 is giving us an angle and seems to think that we can give our answers in exact form. That's because this reference angle here is 60 degrees. And we know the side ratios of a special right triangle that has an angle of 60 degrees. And so if this is 60, this one's 30, which means x is the smallest side. So I'm going to label that with a 1. Then my longest side is the hypotenuse, and that's twice the smallest leg. And then that means that this y value is the square root of 3, but keep in mind it is negative since this is a y value. I'd recommend pausing the video at this point, seeing if you can finish up number 5 on your own, and then you can check your answers here in a second. I'm going to move over these ratios again just for the ease of having some more room. So the sine of 300 you should have had as negative square root of 3 over 2. The cosine should have been 1/2. The tangent should have been negative square roots of 3. The cotangent of 300 should be negative square roots of 3 over 3 if you rationalized it. If you had it as negative 1 over the square roots of 3, that's the same exact thing. This one's rationalized, this one is not. Remember that since this is a special right triangle, I was a little bit pickier with whether or not your answers are rationalized. Secant should have been 2 over 1, which is 2. And the cosecant should have been negative 2 over the square roots of 3. but rationalized would be -2 squared, so 3 over 3. All right, so at this point, hopefully these ratios look familiar. We talked about the special triangles the other day in class. That was this part of your notes. And so these ratios do just keep kind of coming up over and over again. What I would recommend that you do is go ahead and turn to our other page of notes where it says finding exact values, and go ahead and complete this page of notes. Pause the video, and I'm going to go ahead and show up some of the answers here in just a second, but this will basically conclude section 5.4. So after you complete this page of notes here, check your answers, you will be ready to work on that homework assignment. Okay, so now to check your answers for that page of notes. Here they are. If you got them all right, great. You don't have to continue watching. I'm just going to briefly talk about a couple of these. This one we just did in our exploration, so hopefully you noticed that that was the same. The first one we were given a point, and so that put us into the second quadrant. Be mindful of which ones were positive and negative. Don't forget that. That is a common mistake on the quiz. Again, I'm not picky whether or not these are rationalized because this isn't a special ratio that we see often. I am a little bit pickier with these ones though because we are have a special right triangle. The last example is unique in that we don't have a right triangle at 180 degrees. So if you think about that angle in standard position, that's not a triangle here. So we have to go back to thinking about our definitions, y over r, x over r, and then y over x, so on and so forth. And so sine is y over r, and the y value here is 0, and the radius is 1. So 0 divided by 1 is 0. Well, when you go to find the reciprocal of that, 1 over 0, we know we can never divide by 0, so that ends up being undefined, which is something we'll come back to in future chapters. Cosine is x over r, and so the x value is -1 divided by the radius, which is 1 unit away. -1 divided by 1 is -1. You find the reciprocal, you still get -1. Tangent is y over x, and so 0 over -1 is 0. Again, the reciprocal ends up dividing by 0, so it's undefined. So at this point, you should have both pages of notes completed, 5.4a and Exploration 5.4. You can now work on your homework section 5.4.